Hello, my name is Gregory Kapfhammer. I'm a computer science professor and a software engineer, and I have a question. Are you a Python programmer who wants to write high-quality software? If you are, then I hope that you will stay tuned to this talk. It will reveal how the use of type annotations can make it easier to add features to your program. It will also show how types help you to find bugs in your Python code. Type annotations tell both tools and developers about the kind of data stored in a variable. If you're like me, then you might have found that these annotations can be terribly intimidating. However, I kept using type annotations in several of my recent Python projects, and now I find them to be tremendously informative. I don't always add type annotations to my programs, and of course, I still get confused and make mistakes sometimes. However, my current view is that when linting and testing are combined with types and type checkers, I write better Python programs with fewer defects. Here is an example of a Python function that does not have any type annotations. You have probably seen many functions like this when you are reading online tutorials. This one is called extract URLs, and it extracts all of the URLs from a column of a variable called df. Let's walk through each line of this function. The first line of the function is its signature. The name is extract URLs, and the input parameter is called df. Next, the program creates a list called URLs. After creating the list, it checks to see if the string URL is inside of the columns attribute of the df variable. If it is, it stores that inside of a variable called URLC. Now, if URLC is not none, it's going to convert URLC to a list and store it in the variable called URLs. Finally, it's going to return the URLs variable. Now that we understand the inputs, outputs, and behavior of this function, let's ask and answer some questions about it. First, what is the type of the df parameter? Sadly, the terrible docstring for this function does not say. If you have programmed with the pandas package before, then you might guess that it is a data frame. However, you would have to study other parts of the program to be sure. The second question is, what is the behavior of the return URL statement in this function? Specifically, what is the type of data that this function returns? In this case, we can scan the rest of the function's source code to note that URLs is a variable of type list. However, this version of the function does not reveal the type of the data stored in the list. If this function was part of a more complex Python program, then it would become more difficult to have a full-featured understanding of the inputs, outputs, and behavior of extract URLs. For instance, if the function had more lines of code, it would be more difficult for a programmer to see that URLs is a list. And remember, discovering that it is a list would not reveal the type of data that the list stores. This is a version of the extract URLs function that uses type annotations. You will notice that the main difference between this function and the previous version is that its signature is different. The first question to ask is, what is the purpose of df::pandas.dataframe? df is the variable, and pandas.dataframe is the type annotation for the variable. This type annotation tells the programmer, and the tools used by the programmer, that df contains tabular data in the form of a data frame. The second question is, how does a list of string describe the output of the extract URLs function? In this case, the type annotation clearly reveals that the list returned by this function must contain string variables. The type annotation will help the programmer to understand the function's output while also enabling tools like type checkers to ensure that all functions calling this one store the return value in a list designed for strings. When I first saw a Python function with type annotations, several pressing questions came to my mind. Initially, I thought, wait, isn't this function with type annotations syntactically more complicated than the one that does not have them? I also thought, are there any real benefits to type annotations if they are going to take extra time for me to write them? And finally, in the context of Python programming, what are the trade-offs of type annotations? If they take extra time for programmers to write, can they realize any benefits in terms of programmer productivity or software quality? Let's investigate some of the challenges and benefits associated with adding type annotations to Python programs. The first challenge is readability. This means that function signatures could be more difficult to read because they contain type information. The second challenge is productivity. This is because programmers often must add type annotations to their code, and this takes additional time. The third challenge is complexity. This arises because programs will now use many additional types and classes when annotations exist inside of them. However, there are some benefits associated with using these annotations. The first is fail fast. This means that programmers can quickly catch errors before they run their Python program. Tooling is the next benefit. For example, text editors can signal problems to programmers as soon as they happen. The third benefit is understanding. This means that developers can have a better understanding of the structure of the data in their program. However, in order to gain these benefits, you have to use the right tools. Let's investigate the landscape of tool support before moving on. The first is the Pyright language server, which you can run in VS Code or NeoVim. The second is the mypy static type checker that you can run in your terminal window or your editor. Pyright and mypy are both type checkers that leverage type annotations. In my experience, they are exceptional tools that have detected many defects in my code before I ran either the test suite or the program itself. In the remainder of this talk, I'm going to use source code and type checker output to tell you two stories. The first is going to be about how to build an easy command line interface with Typer. The second will show how to quickly find a defect that crashes a program. The experiences that I share in this talk took place in the context of building an open source program called WorkNote. It keeps you in the know about the history of workflow builds on GitHub Actions. WorkNote uses GitHub's REST API to download the history of workflow executions. It then extracts, parses, and summarizes the data, and then stores the most important results in CSV files. Let's create a command line interface for WorkNote. If you have not yet tried the Typer package for the construction of command line interfaces in Python, then you should right away. It is awesome. Now we can review this source code segment to better understand how Typer works and how it uses type annotations. The first 4 lines of the function import Typer and designate that the download will be one of the program's main commands. Download's first parameter is a list of GitHub repository URLs with builds for it to analyze. The next 3 parameters are pathlib path objects to files and directories that WorkNote needs to collect its inputs and to save output. WorkNote's command line interface also accepts other arguments. Check out its GitHub repository for more details. This is what would appear in your terminal window if you typed worknode download --help. Using type annotations, Typer automatically generates all of the menus, like the one that you see here. Since Typer knows the type of each command line argument, it can perform error checking to make sure that a person definitely uses the right arguments in the right way. Typer can also convert all of the strings that a person passes into the program on the command line into the correct type for the program. For instance, if the program accepts a string that points to a directory in which WorkNote should store its data, then Typer will convert that string to a pathlib path object without any effort on the part of the programmer. That is fantastic! Now let's talk about how type annotations enable defect detection with tools like Pyright. One of WorkNo's features is that it can create a zip file of all of the results that it saves about the history of GitHub Action workflows for different projects. This feature has come in handy when the data that it downloads is too large to send to someone on a per-file basis. When I first wrote this function, I did so in the way that you see right now. Can you find the bug in this program? Thankfully, Pyright can find it for us. Let's take a look at the error message that Pyright shared with me. Notice that it says argument of type list string cannot be assigned to parameter filename of type StrPath in function write. As soon as I read this message, I realized that I needed to focus on the call to the write function and the parameter that I passed to it. I realized that I had made a mistake by passing results files, a list containing strings, instead of results file, the specific file to the write function. Yes, one extra S would have caused a major problem when I either ran the test suite or the program itself. It is reasonable to ask whether or not I would have found this bug by other means. Yes, I think that I would have, but it was nice to find it so quickly through the use of the type annotations and the Pyright type checker. It kept me in my programming flow and let me build the rest of the system. I'm hoping that you are now saying to yourself that yes, type annotations in Python are tremendously informative. I hope that you will try them out soon. If you want to see a Python program that is using type annotations, check out WorkNo's GitHub repository. Once you have formed your own opinion about type annotations, I hope that you will get in touch with me through my website and leave a comment on YouTube. Are you interested in seeing the source code for these slides? Check out the GitHub repository below. Thanks for your attention. Now get out there and write some Python code with type annotations.